All right, hello, Alvin ISD mathematicians. Today we're going to be looking at percent increase and decrease. So first off, what is percent change? So percent change is how the amount that something is increasing or it's decreasing compared to an original amount or the original whole. And we use it as a percent out of the original value. So we're very used to seeing part over whole relationships, which is equivalent to percents out of 100%. And in our case today, the percent change out of the original percent, 100%. So we're creating and using equivalent ratios to identify what percent something is increasing or decreasing by, always compared to the original, the starting point. So the first example, Kayoshi runs 20 miles during the first week of cross-country season and 27 miles during the second week. What was the percent of change from the first week to the second week? Label your answer as an increase or a decrease. So first, I see that we started at 20 miles that first week. So the first week we were at 20 miles. And then the second week we were at 27 miles. So from week 1 to week 2, I increased by 7 miles. That's how much I changed. So I know that this is going to be a percent increase because I went from 20 to 27. And we can represent it multiple ways. I can represent it in a ratio table, or I could also represent it in a strip diagram. If I draw a strip diagram, this would represent 100%. The whole strip is one whole. And I know that my original whole was 20 miles. But we added on 7 miles. So I added 7 miles to get to 27 miles. And now I want to know what percent I added. So I'm looking for the percent that I increased. If I changed by 7, I need to find what 7 out of 20 is. So I'm going to use my strip diagram to represent this in a ratio table. So I know that I'm going to use part over whole. So 7 would be my part, and the whole would be the original 20. And I'm looking for what part or what percent that is out of the original 100%. And when I solve ratios, I know I'm looking for multiplicative relationships. And I see a between relationship that from 20 to 100, I can multiply by 5. So 7 times 5 would give me 35%. So it was a 35% increase. For our next example, Elena scores 15 points in Monday's basketball game and 6 points in Wednesday's basketball game. What was the percent of change from Monday's game to Wednesday's game? Label your answer as an increase or a decrease. So I'm already seeing that Monday, she was at 15. And then on Wednesday, she was at 6 points. So she went from 15 to 6. So I know that I decreased here, but I need to find my amount of decrease. So going from 15 to 6, I decreased by 9. So this amount, this 9, that's how much I changed. So I changed 9 comparative to the original of 15. So I'm going to create a ratio table that still shows my part out of my whole. My part, which is that change, was the decrease of 9 out of the whole or the original, which was 15. And I want to find what percent that change was. So I want to know what percent out of 100 that was. Well, I see that there is not a within relationship between 9 and 15, and there is also not a between ratio or relationship between 15 and 100. So I'm going to see if I can simplify 9/15. So I see that they are both divisible by 3, so I'm going to divide 9 by 3 to get 3, and then 15 by 3 to get 5. So 9/15 is equivalent or equal to 3/5. Now that I am at 3/5, now I see a relationship that is between. So I can go from 5 to 100 by multiplying by 20. So 3 times 20, because I want to keep it equivalent, so I'm just making equal fractions. 3 times 20 is 60. So this was a 60% decrease. We are going to do one more before it is your turn to try. And this is actually a star question. So this is what it will look like when you're assessed at the end of the year. So we have the price of a sweater and it was reduced from $20 to $12. By what percent was the price of the sweater reduced? So we want to know what percent the sweater was reduced. Well, I don't know how much it was reduced by, but I know that it started at $20 and then it sold for $12. So the sweater went from 20 to 12, so that change was a decrease in $8. So I want to know what percent that change is, though. So I will set up a ratio table for part out of whole. Now, 12 is a part of 20, but it is not the part that I'm looking for, because I don't want to know what percent I'm paying. I want to know what percent it was discounted or reduced. So my part here will be 8 out of the original whole of 20. And then we want to know what percent that is out of 100%. And so we want to create equal ratios or equal fractions. And I see that I can find a multiplicative relationship between 20 and 100 by multiplying by 5. So 80 times 5, because again, I'm creating equal fractions. 8 times 5 gives us 40%. So the price of the sweater was reduced by 40%. It was a 40% discount. And just for understanding, if it was a 40% discount, then that means I had to have paid the other 60%. So 12 would represent 60% of the original. So here we have our answer, which is letter D. All right, guys, at this point, I want you to pause the video, and I want you to try this one on your own. All right, guys, welcome back. Let's look through it and see how you guys did. The owner of a bookstore buys used books from customers for $1.50 each. The owner then resells them for 400% of the amount he paid for them. What is the price of the used book in the bookstore? So if you applied our previous strategy of setting up part and whole relationships, I know that 100% is shown by 1.5. Actually, I'm going to reset this up a different way real quick. if I am comparing percents to the number values, I know that 100% is the same as the $1.50 that he sells them for. But he says he resells them for 400% the amount he paid. So if 100% is $1.50, then what would 400% be? So I immediately see a multiplicative relationship here of multiplying by 4. So then 1.5 or $1.50 times 4 gives us $6. So a used book in his bookstore is worth $6.